There you go. This chapter is building, like it talks about building an app, but the thing that I like, it goes deep into security of using Istio, security, also integration with the JWT, and then authorization, authentication, which I like, and I have questions. And also guess that Mark was the one that wrote this, because I think at the beginning it talks about moving from Microsoft to Java, and then founding Traveler. Um, is that correct, Mark? You wrote this
Yeah.
chapter?
That first part of the chapter, that monologue on monoliths versus microservices, is mostly my own kind of experiences growing up as a wee little developer, um, and walking into what you would think of as a legacy environment, being like, hey, we should rewrite all of these monoliths into, they didn't exist, they weren't microservices back then. Back then it was, going to date myself here, Microsoft DNA with 3-tier architecture, where you had your presentation logic, your business logic, and Microsoft transaction services, and your database was just your data tier. And at the time it was like, yeah, that's all great, and that makes a lot of sense, except what's the benefit to us? Like, what's the benefit to our customers of spending all of this time rewriting these applications that work into this, what they would have called academically cool infrastructure. And
Would you
it was just,
mind
it was
if I
eye
say
opening.
something, Mark? So I happen to have an Istio course online, and this is how I started as well, like from monolith to microservices, because this is how it makes sense to explain Istio and why you would need Istio. So this course ended up partially on YouTube from the platform. They shared, some videos, and everyone says you want to skip the first 5 minutes of monolith microservices discussion and move on to the classic YouTube comments were like this, like, skip the first 5 minutes. I'm like, but that's the whole thing.
Yeah, it's and I am a big fan of monoliths. I think monoliths have gotten a lot of a bad rap over the years. Microservices make a lot of sense where they make a lot of sense.
Yeah.
But they're I am one that says, you shouldn't go with microservices just because.
Yeah.
Because
So,
at a high enough level, anything is a monolith.
yeah, and it's my experience with monolith, or the word monolith, is I think some of you already know, I spent 20 years in IBM. I did 20 there. And it was Java. Java was the name. Everybody, a lot of companies build their businesses around J2EE, Java architecture, and then running on a runtime, right? It could be JBoss, or it could be Tomcat, or it could be in IBM was called IBM WebSphere, the Java runtime. But you wrote once, and then that Java could run everywhere, Linux, Windows, anywhere for the JVM. But that was my experience of like businesses, a whole business, right? Different departments and everything wrote in a single monolith, meaning that the deployment was, a single WAR file. You can have multiple application servers, but all of them did the same, right? All of them had the capability of reading, and all of them had the capability of writing. And the trend to microservices, I don't know, came about, at least from my perspective, came about around when containers came up, on splitting things, and it became a fashion thing, right? And it's a fashion, like we still live in a fashion. I think Kubernetes is a fashion. I think it's recorded. But a lot of businesses were not like see the benefit of like, why would I write my thing, or even just keep using Java, but split the deployment or split it into microservices. And a lot of businesses didn't know how to do it, didn't know why to do it. And one funny story is there was a business that did the work, spent 6 months, split the monolith into 6 microservices, Jenkins, and it was more about the DevOps pipelines of like building them separately, having a pipeline, having Jenkins, building the container, running Docker, no Kubernetes, right? just building a VM, Ansible to set up the application server WebSphere, and then all of the 6 microservices had to deploy at the same time, and then tested, and then the app was going to go live, and they didn't advance anything. The release took the same amount of time. It was more complex. They hired more people for DevOps, but they didn't get the point of like building the separate 6 microservices independently with API. So at least that's one story that I remember when I was hearing a lot of people like moving from monolith to microservice because what's the cool thing to do? I don't know. Other people had similar stories. I think this was like 10 years before Kubernetes, right? So 2013, 2012. But for one of the main reasons that I think I saw people moving was performance, like CQRS, of separating because of cost. Like they needed to scale for, let's say, for reads, and then writes, and then some applications were not used. Like they had a lot of waste. So I think those the ones that I successfully saw like benefits of like splitting CQRS and then moving to messaging.
Yeah, I mean, I'm not bashing microservices at all. I think it's a great pattern. It's just like any other pattern. It's got its when it works best, and it's not a perfect fit for everything. I don't remember if I got into this example in the book, but like when I first started working in the identity management field, I was working with I was first introduced to a company called Waveset, eventually got bought by Sun. And their kind of claim to fame was they were this monolithic Java application where it was just one place to put all of your identity infrastructure and all of your identity provisioning. You didn't have to build it across separate places. And it was easier to deploy. It had a lot of downfalls, but it was much easier to deploy. And then I later started working on a customer that used the IBM Tivoli approach. Yep. And anyone who's used Tivoli, I mean, it's basically what you would call today microservices. Like it was all broken up into different components. Each one had to be managed differently. So in theory, you had something that scaled really well, but in practice, it was such a beast to manage. And between getting all the connections working and whatnot, and when you write code, right? Like if I do a method call from inside or function call from inside of a bit of code, that's easy. I need to do an RPC call, that becomes a lot more difficult. That just from a developer standpoint, how much of time and energy of microservices is spent with the part of making that method call. So if I don't have to add that complexity, why do it? So, I mean, microservices are great. They're great for certain things, but really the point that I was getting to with this is that Istio isn't just for microservices, right? Like it's an ingress controller. It's got a lot of powerful features, even if you're not using microservices. And so, talking, once we get through the like why microservices and whatnot in this chapter, we dive right into the tech. Like, okay, well, if we're going to deploy a monolith, what does that really look like on Istio? And the fun thing was we said, okay, well, Open Unison is a monolith, so let's deploy it. One of the things that a lot of monolith applications, a lot of front-end applications have as a requirement is session stickiness. When the load balancer, establishes you to an application, your session doesn't move across those applications. So, making sure that, oh, I do not like that at all. There we go. Sorry, I'm getting used to these new earbuds. How do you, your session doesn't travel across application servers necessarily. So how do you tell Istio to handle that situation? So we dive right into like how the gateways and the virtual services relate to each other, how to configure Istio to allow sticky sessions. So like with Nginx, it's just an annotation on the ingress object. With Istio, you've got to create a couple of objects to actually make that happen.
Yeah, so you show in the book, you show an example of like deploying one service, right? One monolith, which is Open Unison, and then putting everything that needs in front of it, right? What do you call like back in the days, I don't know if it's still front door. That was a popular term. Now it comes back to my mind. The front door. Everybody talk about that. I think even books around that, like the front door to Open Unison. So I don't know if in the last chapter it covered this, like the objects for Istio. So this one is I think in the previous one it covers like deploying Istio. You get a like you said, a ingress. I don't even. This is confusing, right? Ingress gateway, like it's just an ingress. It's like it acts as a entry point, right, on everything for that system of a mesh, let's say, right? But then you have to declare these gateway objects to say when somebody comes into that front door, which I'm going to call ingress, then if it matches a host and a port, then it belongs to this gateway. This gateway now has control over what goes into that. It's like the first check, I guess, or the first door. But the thing with this object, that at least when I started working with Istio, it was a little bit confusing because this gateway is a namespace object, right?
Yeah, I mean, the gateway and the virtual service combined are what you typically think of your ingress object with the legacy ingress rules. So you got to take those two separate concepts and smash them together in order to get a working ingress into your cluster. Just launching the lab here.
Or maybe Sevi knows. I also have configured systems where the gateway, the host is star. Like it doesn't matter. Like it's like taking over like all traffic for this cluster is take one of the Istio ingress gateway that you deploy and it's star. And then in the virtual service, you can put the host. I'm trying to remember. I think I did some deployments like that. You don't have to put a host here. You can say star. And then in the virtual service, you can choose the host. In this case, you separated it. You decided like this gateway would only handle these two host names, like SO and SDB.
Yeah, because this is actually taken. Excuse me. This is actually taken right out of when. So when we deploy Open Unison, our Helm charts include objects for the ingresses that we've tested against. So we've tested against Nginx, Nginx Plus, Traffic, and also Istio. So this was literally generated. This is a snapshot of what gets generated out of our Helm charts, which is why we did it very specifically. But yeah, there's a lot of flexibility if you're going to use specific hosts or wildcards.
One thing that I feel like when you put star in your gateway, it puts more granular definition, or you have to put more definition in your virtual service to actually decide which host goes where within your service mesh, right? So when you say start in your gateway, it accepts traffic from any hosts. Then in your virtual service, you have to define, because it's the next step within the service mesh, if I'm not mistaken, and if I got the question correctly.
Yeah, the system I refer to, well, is one that I built different reference implementations back in the day. I started using Istio, I think, when I co-founded Knative. Istio was the only thing imported in Knative. But the gateway was an object that is very like tied to the port that is open on the ingress, right? It's 480 and 443, that specific number. So I tend to take gateway as a platform team concern and object, and not give the tenant, the developer of the namespace, access to the gateway, because they don't have to mess, right? So that's basically how I did it.
Makes sense, actually.
I made the gateway deployed by the platform team, by the infra team is one of them, deployed in that namespace. The only thing that I felt weird, that I wanted to see was like a gateway, a higher level, cluster level scope gateway that generated these ones. So at least that to me, it still was a little bit confusing of like, because this object, I felt like the platform team had to own it. Developers didn't. Developers just mess with the routing of the greater virtual service, and then I put rules in the virtual service. This was kind of like a mechanic thing that it had to be done. Like without this, stuff usually didn't work. But it's something to, if you're starting with Istio, you set it up like Mark says, like you set it up and then you create one and then you forget about it, right? You put star maybe. But in this case, in this example of the book, there's a TLS that gets presented, telling the ingress gateway, hey, for this host, present this certificate, and that certificate, I think Mark put the clarification in the book saying that secret is on the Istio system namespace, on the developer or the tenant. Because again, it's kind of configuration. You're configuring the ingress of it. Yeah, and then pass through. Simple. I think simple. Can you clarify? I think pass through is just give me everything in it. Like just pass through everything. Like don't even open it, right?
Yeah, so in this instance, we used pass-through because Envoy does not support the legacy Speedy protocol, which up until I think 132 was the only protocol. Yeah, 132 ClientGo SDK is starting to use WebSockets for exec, which piggybacks copy. I think port forwarding is still Speedy, but they're finally. Fun fact: I tried to do this with ClientGo SDK back in 2020 and failed miserably. Well, that's not true. I got to the point where it worked pretty well with exec, and was getting ready to submit, and we started talking through how we would do it with port forwarding, and it just all fell apart, and I lost track. And that's when we forked Kubo IDC proxy instead. Yeah, so we need the pass-through because Envoy just doesn't support Speedy. Like, 99% of network infrastructure in the world doesn't support Speedy. So pass-through, the Envoy proxy does not decrypt the traffic coming in. It's not a TLS endpoint. It's literally just taking that traffic and forwarding it straight on through without any type of, it's not doing any type of re-encryption. It's not, it's not injecting any identity. It's not looking at it. So it is a complete TLS pass-through of the data into the downstream system. In this case, Kubo IDC proxy.
So it would do it on both hops, like the ingress Istio, which is again another envoy, and it will do it on the sidecar of Open Unison. Like it will like do the two hops and then not touch anything.
Let me
or
double
have
check
a
here.
sidecar on Open Unison.
Well, so this is actually to this is to Kubo IDC proxy. This isn't to Open Unison. So Open Unison does not require it. Kube control get pause. Kube control. Okay, so there is a sidecar on Kubo IDC proxy. So yeah, so I think it actually re-encrypts the traffic using its own. It re-encrypts the traffic to the sidecar, and then from the sidecar drops it in.
I see. This.
I think.
Yeah, this object has three sections. I forget. Like this is the last section. Now understand. Okay. And then you have this is the virtual service, right? Specify the gateways that you want to use.
Right. So that's how you bind your Kubernetes service to your gateway.
Yeah, and then this is another. I don't know. I bring all my pets each of the year. This is another one that is because the gateway, the way my system worked, right, was the gateway is something that I need control because it's like the like the inbound, the front door. So that was a gateway object that developers didn't have to touch if you have to deploy an app in that tenant. But then when they created the virtual service, then having a gateway here, they can say, well, I'm going to specify a gateway that exists in my namespace. So this is how they can be saying, well, I want to listen to that other traffic over there that is not in my namespace, right? So the multi-tenancy part of it. So that's why the gateway needs to be this namespace. But that's my pay. But the gateway is in a namespace that they can, if you give it access to write anything in that namespace, then they can touch the gateway. I don't want them to touch the gateway. So that was the pet. Maybe now it clarifies my assumptions, my pet peeve of like not giving us to RBAC access to developers on the gateway. That you can specify one that I created for you, or maybe one point I was just injecting it, like just create a virtual service without it, and then I would inject it and name it something with your namespace or something. Does that make sense, Mark, for multi-tenancy or not?
Yeah, I mean, I think the nice thing is, it's kind of like ingress objects, right? Like this is the closest that you're going to get to what you would call an ingress object, because the gateway is really defining your network side infrastructure, whereas the virtual service is defining how you want to integrate your application with that hardware. So it's kind of got to be namespace. And then you've got to use something like an OPA or a Gatekeeper or Caverno or something to make sure that when developers create the virtual service, everything still links up.
Yeah, and it's a simple like it's not a simple like setup. It's a simple requirement saying I have two teams, team 1 and team 2. I'm using Istio, but team 1 should not be allowed to just hijack and listen the traffic of team 2. Simple, right? Like a simple requirement. That people like everybody in the room is like nuts, and then you ask like who is going to configure this in Istio? What parts do we need? Well, we can use OPA, we can use Kubernetes, the gateways and namespace. We have to do the RBAC. How do we onboard a namespace? That's where I think the complexity is to start like coming in. Not necessarily when you have one cluster and then one tenant and then one app and then like that's it, right? Everything is configured completely. At least that was my experience. So you have to be more careful.
Yeah, absolutely. I mean, it's like anything else with multi-tenancy. You got to automate it. You got to make it consistent, and you got to have guardrails in there to make sure that people don't, you're not going to protect yourself necessarily against a determined actor with the guardrails, but you want to stop the developer who accidentally, misconfigures something.
Yeah, and you can create different matches, I think, and then you can have some enterprises, what they do is they don't share the ingress. Like create multiple ingress Istio ingresses, and then give team one your ingress and team two another Istio ingress, and then that's where like the more things you configure, the more complexity you have to have, and more DevOps, more GitOps into it to do multi-tenancy. So that's kind of like, I don't know if people have questions or comments around the setting up a multi-tenancy. I know that when I used to work with OpenShift in Red Hat, their Istio flavor of distribution in OpenShift, their operator supported out of the box creating like tenants Istios. You have different Istio instances. Like there was no system Istio namespace, only one. Like you can create it. They had an operator that you created an object that requested to the system, I want my own Istio system, and then you deploy the whole thing, like your own Kiali and your own like the whole stack and everything, and it was separated. I think at that time in open source was difficult to do it with open source, not impossible, but I think that Red Hat created an operator to automate that.
Yeah, that's not really multi-tenancy. That's single tenancy, easily repeated, right? Like when you're when you're sharing like that. Like I know I've got customers that they do multi-tenancy, and it's a lot easier just to do make sure you put the admission controllers in place to make sure y'all don't step on each other, and tools like that, or being able, like I know like Anthos supports multiple versions of Istio, but it's not, it's we have multiple versions of Istio and cluster that you can use based on your compatibility, but
that's true.
each
Also,
Istio is multi-tenant. And then they run Kiali in a multi-tenant way where the SSO obeys the RBAC rules of the cluster.
oh yeah, that's a good point. I didn't bring up the version of Istio. Not everyone. I think Istio is the same cadence of like people not upgrading Kubernetes. They install it, and Istio moves very fast. The versions. And when I say moving very fast, people say, "Oh, that's great." Well, not great when they move very fast of like supporting your old version. Because they're not going to support N-16, right? They support, I don't know what's their policy today, if it's N-2 or N-3. I'm not sure if somebody knows. Maybe Alejandro knows. N-2?
Yeah.
Yeah.
Hey, Victor, did you have your hand raised?
Oh, there's a hand raised? I didn't see it. I'm a little.
No, sorry, it was an accident.
Oh, okay.
So this is the section about the sticky session.
Yeah. So this is where we actually figure out how to tell Istio, hey, we need a sticky session on this, using this optional destination rule, which is like, it's kind of weird because it's something that I would think would go into the virtual service.
Where does this go? In the destination rule or virtual service?
Yeah, destination rule is its own object. So it kind of is a peer to virtual service. It's not really a child to the virtual service. It's got this weird symbiotic relationship with it. But it's something that I would think you would put into the virtual service. But yeah, so you've got the destination rule, and that's how you tell, amongst other things, how to do sticky sessions based on cookies.
And it's because you have a requirement on having sessions?
Yeah, Open Unison doesn't do session clustering, so you have to have a sticky session down to Open Unison for each request. So that's why we ended up that's how we ended up testing out this particular rule.
I see. Yeah, a lot of at least Java applications. I used to work a lot of Java enterprise applications. That was like number one requirement on when they moved to Kubernetes. They wanted session affinity, right?
Yep.
And so this is doing the Istio. Does the other? I'm trying to remember if the other controllers, ingress controllers, supported this or not. I think always that was the question.
Almost all of them do. At least the ones that I've worked with. Istio does it. Ingress, Nginx does it. Nginx Plus, you have to buy the commercial version. So the
See?
open source, the open source Nginx, the one that
Doesn't do
comes
it.
from F5, does not support it. But the paid version, Nginx Plus from F5, does support it, and Traffic supports it.
Traffic, okay. Yeah, that's always a requirement for those enterprises that are trying to move to Kubernetes. And actually, sometimes they pick Istio just because it has it, and then just in case in the future we need Istio. Like usually that was the they wanted like one thing from Istio, and then like, well, okay, that's fine. You're not going to use the whole thing, like, well, just in case.
Yeah.
Well, if you can do it with something else, right? I guess, you can do it with something else. You would do it. Kiali, you talk about the authentication with Kiali. Let's
I've
move
actually got
into
the demo running.
Oh, go
Because
ahead.
last time we did, if I can share.
I'll stop sharing.
There's a button somewhere here, right? Oh, there it is.
Yeah.
So share screen, window, or no, entire screen, and I want to do this one down here. So this is one of the few chapters where we say start with the lab from the previous chapter. So I took the lab that we ran last week, and then there were two scripts. There's this deploy Open Istio script, which goes ahead and deploys Open Unison, deletes out all the virtual services, recleans it up so that it's all integrated, and then integrate Kiali. So last time we were showing off how, here you got Kiali, you got Jaeger, you got Grafana, and there's no security, right? Like security is not my problem. So here we actually have, so if you were here for, I think it was chapter 15, we ran the deployment. So in this chapter, we said, okay, we're going to go ahead and integrate SSO into Kiali. And so the big difference here is it kind of went fast, but you can see that Kiali knows who I am, right? Like it knows I'm Matt Mosley. So when it communicates the API server, just like with the dashboard, it's doing it with my enterprise identity. It's like I'm a cluster admin, so I can see everything. But if I'm not, if I own only a particular namespace, I can only manipulate things in that namespace. But I still have, the whole of my Kiali implementation, which is nice. So you can see, like, we're just looking at Open Unison here, but you can see the different configuration points. So it still works. Same thing with Jaeger.
I never configure authentication with Kiali. So this user, how do you grant access to the user? What it's used to grant access to what in Kiali? What can this user see in Kiali?
So, excuse me, it piggybacks off the connection into Kubernetes. So when it talks to the API server, it does so using the token. So the architecture here is actually a reverse proxy. So I don't think it actually does it. If I add this and Istio system, will this show the way I want it to? No. Okay. Well, I guess that makes sense. So the traffic comes into Kiali via Open Unison's built-in reverse proxy. So Open Unison authenticates the user and then injects a token, short-lived token. I think it's good for like 2 minutes, 3 minutes maybe, incident request down to Kiali. Kiali gets that token and just passes it on to Kubernetes. So Kiali's not doing any session management. It's not doing any, in this case, because it's using impersonation, it's also adding the impersonation headers. So whatever I, as the user, am able to work with, that's what Kiali is able to work with.
I see. And then Kiali backend talks only to. I thought Kiali was able to talk to Prometheus and Jaeger and do Jaeger query. Jaeger.
It is. And again,
and it uses Kubernetes token.
It uses that same token, yeah.
Yeah, this is super. You're showing like very easy to because it's working, but it's super difficult to somebody that doesn't know how to configure this systems. This authentication is super painful, like to get it working.
Yeah. I mean, this was a lot of fun to be able to do because when I wrote this part of the chapter, it was like 15 minutes. Like it was actually stupid easy to do. I was actually the author who donated the code to Kiali to be able to handle the pass-through. Kiali had originally had the ability to do OIDC, but the way it was doing OIDC, because I think with a lot of cloud native management applications, they don't do sessions like well at all, because a lot of them are written in Go, and Go's HTTP service has no built-in session management capability. So what they'll end up doing is they'll just encrypt it and put it in a cookie. And folks who have been writing web applications for a long time know that that's not really an effective way to do things to manage session. So we take that away by putting the reverse proxy in front of it, and it just vastly simplifies the implementation.
But on the back end of Kiali talking to Kubernetes, that was already like implemented.
No, we added. We donated the code so that it would work with both impersonation and tokens. So like in this instance, the token that actually gets sent is Open Unison's token because it's got to do an impersonation. And then it adds the impersonation headers on top of it. So what Kiali actually sees is there's an authorization header with Open Unison service account token. And then there's a, then there are headers that say, this is really M. Mosley, and M. Mosley is a member of these groups, and that then is what the API server interprets for binding to RBAC.
Impersonating that user, right, with that service account from Open Unison. And what about Jaeger?
I don't think actually Jaeger knows or cares.
Right?
Yeah, Jaeger I don't actually knows or cares.
I don't think Jaeger has login or single sign-on. I think it's just the front end. So you have to put something in front of it. Interesting. So wait, so if I run this in production, everyone has access to Jaeger?
If you provide that access, yeah. I mean, I don't think the folks that I know that are running this in production will only expose Kiali. They won't expose Jaeger directly. Because Jaeger has absolutely no sense of security.
Interesting. I'm trying to remember when I set it up with in OpenShift, if we use the authentication from OpenShift to as a session cookie, or maybe they have a different version of Jaeger.
Well, I think going back to OpenShift, I think they did it in a way that everybody had their own Jaeger.
I see. But even to access it, right, in an ingress from the internet, it has to be authenticated.
Yeah, and I think Stephanie, if you're talking, we don't hear you.
Sorry, can you hear now?
We can.
I would say probably in these cases where applications are not like natively having authentication, we would like have like auth proxy. It really
Something in front.
yeah, like it redirect automatically to some SSO or some authentication system like Keycloak or Okta, and then it redirect you to your page with your header.
Yeah, that's exactly what we're doing here. It's just instead of using OAuth 2 proxy, we're using Open Unison's built-in reverse proxy. Exact same concept, though.
Nice.
Yeah, and Grafana. This Grafana has Loki or just Grafana? I think
This is just straight up Grafana and Prometheus to support Kiali. So there's some dashboards in here. But again, we have SSO set up. So Grafana does know identity. So same type of deal where we're integrating the identity directly into Grafana.
interesting.
Because it's an enterprise book, and you can't have security enterprise without some security.
Yeah. And this is the same user, right? Same. Are you using the same cookie from the browser? Or is one Open Unison with the same expiration and everything?
Yep.
And that's good because you don't have to like log in again multiple times to every time you visit something.
Exactly. So this becomes your one-stop shop for all your cluster management apps.
Do you have the app deploy from the example? The store?
What do you mean?
From the chapter, the microservice?
Yeah, I mean that's the next one. I haven't actually deployed that one yet. No. Come here, building the microservice. So this is where we actually start to have some fun actually diving into building microservices. So let's see here. I don't know how much of this we'll get through, but where's...
Or you can just show the book. Was going to ask that you had a section that I really like there on OPA, but I wasn't sure how OPA was configured. I wasn't sure if the app was talking to an OPA endpoint or you have something as a validation webhook with OPA. That part I couldn't understand.
Yeah, so the next couple of sections, being an identity geek, I love getting into authentication, authorization. The we get into how Istio actually works with ID tokens, how you can authorize based on the information in it, and then we get into how to do token exchanges. That's one of the big things with microservices. That is the pain point is how do you securely talk from one service to another across a multi-service transaction. And then we get into authorization. So when I first wrote the book, so this is the second iteration of this chapter. I wrote this chapter in the second edition. We didn't include this particular part, and the recommendation was, look, don't bother doing any kind of complex authorization at the control plane layer or at the Istio layer, and the reason was that it can be really easy to do it wrong. Like it's really hard to do right because OPA, OPA in particular, you've got to plug it with all your data that you're going to use. However, since the second edition was written, this has become a lot easier. OPA has some tools that are better, the commercial side, but then you also have offerings from Google and a couple of commercial offerings that just make this use case a lot easier. So I decided to end up adding it into the book. So what we're doing here is we're going to use OPA, but we're configuring, we're actually configuring, this is the rule itself.
Yeah, the rule is like making sure that the user belongs to this group, but it doesn't belong to this group, and then let him in.
Exactly. So the rule itself is pretty straightforward. What we need to do is, where is it? Maybe I just put it in the code. Okay, deploy Open Istio. So you deploy the mutating controller, and then the policy and Istio D get configured inside of Istio. So you're configuring Envoy to basically say, go call this webhook on each request. So that's pulling the authorization decision out of your microservice code. I will say for a monolith, it's probably not going to be super helpful. There have been a lot of attempts at this over the years to try and externalize authorization decisions, and they've all failed pretty miserably. But if you're using a microservices architecture and you've got it designed, at small enough levels where you can make the authorization decision outside of the call, it can be really nice.
And that called Envoy external, I guess that's kind of a plugin for the Envoy. I think they're called plugins. I don't remember.
Yeah, it's an Envoy plugin.
Is that called from the sidecars happening? Because then we can handle.
Is it from the sidecar? Right? I think it's from Istio D.
Well, Istio D, it's just to configure the envoys, right? But this code runs in the Envoy. Envoy is the one making the call. To this endpoint, but I'm guessing it's going to be in all envoys, because then you can use this from east to west, right? One app talking to another one.
Right. That's a good question. I don't remember. It's been a while.
Okay. And then that mission, I don't understand why you need a mission controller if you're just going to run a webhook with the OPA API for Envoy to call.
Deploying an OPA mutating mission controller. Oh, because the OPA service, OPA doesn't run as a service. OPA runs attached to. That's right. Okay, now I remember. You're right. It attaches to the Envoy, but OPA runs as a sidecar with the Envoy. It doesn't run as a, in this particular instance, it doesn't run as a centralized service.
It's costing me an arm and a leg now.
Yeah.
If I have 1,000 pods, I will have 1,000 little guys. It cannot be run as a central thing, or it's just convenience.
I think the reason why it's done this way is because you need that data to be able to make decisions off of. So in this case, we're just making decisions off of the JWT, so it's not that big of a deal. But if you have external data that you need to make decisions off of, you have to populate that OPA database. So the thinking is that each user will want to keep that data close at hand.
Interesting. This is very cool. That's why I got to this section, but I didn't see a picture or say a diagram. I was looking for a diagram to understand this.
I'll be honest. I think I had gotten to this point. I was starting to be like dragging because we're getting near the end.
But it's super interesting, this use case, because it's a latency, right? You also do it for latency. Radio blast radios, right? To like not have single point of failure, but also latency because the Envoy is just doing a TCP call on the same IP namespace, right? On the same local host, and all the data is there. Doesn't have to transverse. So in terms of, I was joking about the cost, right? Because everybody runs on the cloud and it's very expensive. But when it comes to businesses, right, latency, high availability is more important, and that's meeting a requirement, right? And that's how you do it properly. So I like this and the example to be everything in the pod.
Yeah, and we've got a couple of other like we used OPA here mainly for two reasons. One, it had good examples, and two, because we were already using OPA for within the cluster. I like the idea of showing the reusability of a skill. But Amazon's got Cedar. They're doing really exciting stuff with that, and now Cedar has an emission controller for policies inside of Kubernetes as well.
Yeah, that's my team. We're looking into adding it into, well, we can add.
Uh-oh, we lost Carlos.
Normal things that you do in policy, but the RBAC saying like, and this is what I was talking before, that use case about the multi-tenancy of like, you're allowed to configure the gateway as long you created the gateway, right? And since you didn't create the gateway, you're not allowed to create it, only the platform team. That way I don't have to create rules of like by name or like by type. It's just like I created it, I add a label, and then by label, I'm able to edit or not that policy. So that with Cedar and that Kubernetes authorization, it's a webhook. It's another validation, right? Webhook to run logic and Cedar. So in theory, you can put Cedar in Sidecar, right? The same thing, and make an envoy proxy called Cedar. That's why you included this bullet point.
Yep. And then Topaz is another one that's kind of interesting, where it combines OPA for the policy language